All right, let me go ahead and start talking through 5.3. All right, this section covers some material that you should be relatively familiar with. I'm just going to talk about a couple things on it, and then we'll talk about the remaining ones tomorrow. Okay, Pythagorean Theorem involves right triangles, and most of you know the relationship. The Pythagorean Theorem states what? In a right triangle with legs A and B and hypotenuse C, the sum of the squares of the legs is equal to the square of the hypotenuse. And so this is a relationship that's pretty familiar to anyone that's studying geometry. And the application of it should also be pretty familiar. Make sure that you are comfortable working with radicals. So if I gave you legs of 1 and 2, you could solve for this missing side, the hypotenuse, by squaring the legs, adding them together, setting that equal to the square of the hypotenuse. And so 1 squared and 2 squared give you x squared. When you perform the calculation on that, square root both sides, you get your solution of square root 5. Now, when you are looking to identify correct answers, online it'll probably look like this. Square root of 5. If you're asked to enter numbers on a quiz online, where it maybe says round to the nearest hundredth or 3 decimal places, then you'll have to actually calculate the approximate answer. So the decimal form, make sure you can work in both decimal form and the exact form. Take really quickly and find what would you get for x if I gave you this right triangle. Now again, remember, Pythagorean Theorem only works for right triangles. But what would be your value of x if I gave you this problem? What'd you get for your x value? 3. And you can do this mentally. You can work backwards. 5 squared minus 4 squared is equal to 9. The square root of 9 is 3. So that gives you this length. What's unique about this is all 3 sides of this right triangle are integer values. And anytime that happens, it's referred to as a Pythagorean triple or a common triple. So a common triple has 3 integer sides, and they're not square roots or radicals. The 2 most used common triples are 3, 4, 5, 5, 12, 13, and all the multiples of these. So these are going to appear very likely on any standardized testing that you take. They like to use these multiples. Now, when I say a multiple of this, what I'm referring to is if you get a right triangle and you have something like this, 20, 16, and x, and they ask you to solve for x, it can save you lots of time if you look to see, is there a number, one of the numbers that's given that fits one of these patterns. It's usually easiest to look at the hypotenuse, but it's not always going to be given to you. That might be the unknown. But if the hypotenuse is given, look to see, can we factor out a 5 from 20? Yeah, 5 times 4. So if you look at this, you want to test to see, is 4 a multiplier that gives you a common triple? So we look at the other given side. Can you factor out this same common factor of 4? Yeah, it winds up being 4 times 4. And now does it fit the pattern of 3, 4, 5? Yeah, so it's a 3, 4, 5 triangle, but it's a multiple, and the common multiplier is what number? 4. And so what's x going to be? So this saves you the trouble of having to use Pythagorean Theorem if you can match it to a common triple. Okay, so I would definitely look to do that. It will save you time. It's easier to do it than it is when I explained it through this, if you understand what the rationale is behind that.